Hello everyone, welcome back to my YouTube channel Exploration with Sejal. So today we are going to see the surface integrals. So surface integrals are given by this closed integral. This is v dot dA, where v is a function which is a vector function and dA is the infinitesimal patch of area which the direction is perpendicular to the surface. So if the surface is closed, we write it in this symbol, and in fluid dynamics, if V describes the flow of the fluid, then integral of V dot dA represents the total mass per unit time passing through the surface, which is also known as the flux. So let's now solve an example. So here is an example. Calculate the surface integral of this function V 2xz x cap plus x plus 2y cap plus y z square minus 3z cap over 5 sides, excluding the bottom of a cubical box. So you can pause the video here and try to solve by yourself. Let's now solve the problem. So here you have this cube and we have 5 faces. So this is phase 1, phase 2, phase 3, phase 4, and this is phase 5, which is in the upward direction. So excluding the bottom side, we have integral of v dot dA. V is this function and a is equal to 2. So for x equal to 2, we have dA is equal to dy dz x cap. So v dot dA is this v, and dA is the is pointing in the x direction. So we have 2xz dy dz, that is x equal to 2, so it becomes 4z dy dz. So we integrate it. So this is how we get the integral, and after solving this integral we get the answer 60. Next we have x equal to 0, that is for the second phase, and for second phase x equal to 0, so dy dz minus x cap, because it's pointing in the negative x direction. So v dot dA becomes minus xz dy dz, and we substitute x equal to 0 here, so it becomes 0. So for the third phase we have y equal to 2, so dx dz y cap, v dot dA becomes this, and we then just find the integral. Limit goes from 0 to 2, and for z also limit goes from 0 to 2. So we solve this and we get the answer as 12. For the fourth phase we have y equal to 0, so dA is equal to dx dz minus y cap. So v dot dA becomes this, and we solve this integral and we get the answer as minus 12. So then z for the fifth phase, z equal to 2. So for this case we have dA is equal to dx dy z cap, because the normal vector points in the z direction. So it is v dot dA, that becomes y z square minus 3 dx dz, and after solving this we substitute z equal to 2 here. So then we get the answer as 4, and the total flux then becomes 1 plus 2 plus 3 plus 4 plus 5. So we are excluding the bottom surface, hence the answer becomes 20. Now let's also see what is the volume integral. A volume integral is given by tau for a given volume element t d tau, where t is a scalar function and d tau is the volume element. In the Cartesian coordinates, this becomes dx dy dz. If integral v d tau is of this form, so if v is a vector function, then we can write like this. Then in the component form we can just write this in the component form. So x cap vx d tau plus y cap vy d tau plus z cap vz d tau. So let's now solve an example. Let's solve example 1.8. Calculate the volume integral t is equal to xyz square over the prism given in the figure below. So this is the figure. So here we have this figure, and x equal to 1, y equal to 1, z equal to 3, and this is the prism. We have to find the volume integral. Let's now see the solution. So consider this is equal to t d tau, where t is this function x y z square over the prism. So we write this function here, dx dy dz. X goes from 0 to 1, then y, since x is equal to goes from 0 to 1, there is a constraint. So for y it becomes 1 minus x, and z goes from 0 to 3. So remember one thing, the x and y are not independent. Hence we have I is equal to 0 to 3 z square and 0 to 1 x, and we then write integral from 0 to 1 minus x y dy dz dx dz. Then we try to solve this. So what we have here is we have x here kept here, and x is not independent actually. So we are y goes from 0 to 1 minus x, so it is like y square by 2, and then we substitute the limit, so it's 1 minus x square x dx, and this half comes from the fact that it is this y square by 2, so that 2 comes here. So then we have this, then we try to solve this. So we have this one, x minus 1 minus x square x. So we write this in this write it in the expanded form, and then we multiply with x, so it becomes x minus 2x square plus 3 x cube. So we substitute that here and we try to solve it. So this becomes is equal to half into 3 square. Then this becomes x, we try to find the integral of this, that is x square by 2 minus 2 x cube by 3 plus x raised to power 4 by 4, and the limit goes from 0 to 1. So we substitute the limit and we get the answer as 3 by 8. So here we have solved the volume integral over a prism. So thank you for watching and see you in the next video.